So given that we have a log function, and then they write here x less than 0, so we try to see is it this function is a whole piece or just condition case. So as we know that log, apa yang log bawah mesti besar daripada kosong. So when it divided by negative, it's supposed to be less than 1. But here they want less than equal 0. Means that this function is not taking the whole piece. They are taking one part of it. So it is a condition graph. So to get this condition graph, when we want to see the range, we cannot just tutup dan tengok. So that one tutup dan tengok is general. The cluster that I teach you in the technique, that is general for the whole graph. So to get the range of the graph, we have to see what is the remaining part. Alright, so for this log, you want less than equals to 1, and then this is the domain, and then the range of the function generally for the whole piece when you tutup, the log, kasra, range will be negative infinity to infinity. This is general case without condition. So when we want to draw it, apa yang log bawah mesti besar daripada kosong. So this one is an asymptote, and then to the left, and then when x equals to 0, it is y equals to 0. So here, your graph here is supposed to be like this. This is your log. And when you apply the condition saying that less than 0, so we are just apply this. So less than 0, you are just taking this graph only. Therefore, your range of the function, it will be starting from the lowest value, which is 0, to infinity. So it will be no longer in negative infinity to negative infinity. Negative infinity to positive infinity, because this is not the whole piece of the graph already. It's just one part only, which is 0 to infinity. And then for the second part, show the function is one-to-one function. So we will start fx1 equals to fx2. You want to use algebraic method also can, or you want to using graph also can. So graph I already draw here. You just use horizontal line test, intersect one point, so it will be automatic one-to-one. So when you want to put fx1, it will be ln 1x1 equals to ln 1 minus x2. Then you unlock your ln, find out your x1, so move it. So your x1 will be equals to x2, therefore this function is a one-to-one function. Then we proceed for the part C. We want to find the F inverse. We're using composite method. So F inverse x equals to x. Substitute the F inverse into the function. You can get ln 1 minus F inverse. So unlock the ln. It will be base e to the opposite, become the base of indices. And then divide the negative, so it will become 1 minus ex. So I write the positive term first. Then the question asks you to find state to domain. Domain of F inverse, it will refer to your range of the function. State domain. So domain of the F inverse, it will refer to its range of the function, which is 0 to infinity. Then sketch the graph. So we're going to sketch this inverse graph. To sketch this inverse graph, you need axis of reflection, y equals to x. X-axis, y-axis. So look at the log graph just now. The log graph is not taking the whole piece. It is condition which is taking less than 0 only. So our graph is starting from here. So this is the log graph. This is original function. And then when I reflect it, so when I reflect it, the image will come here. That will be F inverse. So the starting point, when you touch this reflection axis, so this is also the point of touching. The image also come out from here. So make sure your graph is labeled. Then we see what is the important marks here. For the first mark, finding the range, just one mark. And then secondly, finding one-to-one. So this is your concept. Make sure you write your conclusion. You get x1 equals to x2 and you write your conclusion. Then finding your inverse. So we want composite method. Simplify here to get answer. So this is your domain of the F inverse. Then lastly, for the graph, firstly, you will see your function. Secondly, you will see your inverse function graph. Lastly, you will see all the label. So make sure you have your x, reflection, y, your function, your F inverse axis, and your point. Starting point here is 0, 0. Label all your point here. So that's all.